And so this is the work we've been doing. We're going to put together a couple of things that we have been working on, which is getting these derivatives. We're looking at really the geometric approach again, or the geometric idea behind what we're around a derivative, right? So taking a look at that first question, you say, what do they want to know? They want you to determine the what? The equation of the tangent line to the curve at the indicated point. So here's my point they indicate. And they want the equation of the tangent line. Now that's at the origin. So automatically, you guys remember when you work with the other functions, these are now trig functions. We're using our beginning algebra. This is what we need to work on. Okay, so this is your first and only point. It's your x and y coordinate. Okay, this is my x1 and my y1. So both of these are zeros here. And so all we have to do now is determine m tangent. All right? And m tangent for the sine function. So they want to know what's the equation of the line tangent to the curve at this location here. And if you guys can see it here, since you have some experience, they want you to find this equation here. Remember, you're going through that point 0, 0, but you're kissing the curve. So we're going to need m tangent for sine at 0. All right. Is that right? You guys okay with that? Did you guys work on some of those things? So m tangent is the derivative of the sine curve, right, at the value x is 0. So that's the definition. So what's the derivative of sine now? Anybody know the derivative of sine? I think it's cosine. Is that right? Derivative of sine is cosine. Okay. We got to evaluate this at x is 0. So we got to know what cosine of 0 is. Okay? Now, cosine of 0, we know is the value what? 1. Is that true? So you found m tangent to be 1. Now, you might say, I don't know anything about cosine. Well, ladies and gentlemen, you want to remember the cosine curve. You know, these things show up a lot in STEM courses. So I remember when I was a student, you know, there's various ways that you guys can remember this, like the unit circle. But some people go straight to the what? To that cosine curve where the amplitude, you know, this is where that 1 is. So since you know those curves, every STEM student should know, like I showed you that worksheet I did, we know that m tangent now is 1 because this is the meaning of, or how we can think of cosine of 0. It's 1. So you go, what does this become? Well, this number now is 1. So everything together, I'm going to copy this and bring this down. We get now y minus 0 is 1 times x minus 0, or y is simply x, and actually you're done now. This is the line that they're looking for. This is L tangent. Okay? Y is x. Now, I'm going to go back to here to Desmos, and I'm going to change this here. Yeah. I'm going to put that equation here. If it lets me. Come on. Oh, there we go. Y equals X. And sure enough, ladies and gentlemen, what do you guys see? That's the equation of the line tangent to the curve at the origin. And that's exactly the same curve that I drew for you guys. So, I mean, I can show off a bit, maybe, you know, bring this in. And it's going to be way at the bottom, which is what I don't want to do, but okay. Can I do a cut? Yeah, cut that. And sure enough, there it is. That's what they're looking for. Equation of the line tangent to the curve at the origin, but it's now for trig functions. Okay, so they can ask you the same questions now even for trig functions. And take a look at this one here. It's very similar now. But now the function's going to be what? Cosine, and then what's the location? At pi over 3. This is the one and only point now. Okay, so here's the x-coordinate, the y-coordinate for your one and only point. I would say go back to that equation. Y minus y1 is m tangent x minus x1. And so the x-coordinate goes here. And the y-coordinate goes where? Here. So y1 is 1/2. x1 is pi over 3. Okay, maybe this helps you see things. And then, as you guys know, what do we need? We need m tangent. And in order to get m tangent, that's the derivative of cosine at pi over 3 now. So let's use that definition of m tangent. And you evaluate that at x is pi over 3. Okay, what's the derivative of cosine? Negative sine. And you evaluate this at pi over 3. And this is negative sine of pi over 3 now. Okay? So if I asked you guys, think about this. What is pi over 3? Isn't that 60 degrees? So I could go back to geometry if I wanted, if I had to deduce this answer, right? Going back to geometry, I might look at my 60 what? So if I can draw that. You go back to that special triangle. 2, 2, 2. However, we bisect this. Means cutting in half, and now you get the square root of 3. So the 60-degree angle we look at maybe here, and then the definition of sine. Do you guys know what the definition of sine is? Yeah, sine. What's sine of 60 now? I got to use that definition of sine. So sine of 60 degrees is, oh, isn't it opposite over hypotenuse? It is. And so this is going to be what number then? Square root of 3 over 2. So my final answer is negative square root of 3 over 2. This is m tangent. All right. So as you guys can see, yes, I'll need to do some arithmetic here, where you get y minus 1/2 becomes negative square root of 3 over 2 x minus pi over 3. So distribute now. And that's plus the square root of 3 pi over 6, it looks like. Is that right? And then add 1/2 to both sides. So this is the equation of the line. It's negative square root of 3 over 2x plus square root of 3 pi over 6 now plus 1/2. Okay. Going back to that picture, it should make sense that the line should have a negative slope here. This is that altangent line. So, yes, it does look like, let me try to draw this curve. This should be altangent. You're barely touching or kissing the curve at that point. And even if I went to Desmos, y equals negative square root of 3, come out of there, divided by 2. Okay. What was the rest? Do you guys remember? It's plus square root of 3 over square root of 3 pi over 6. All right, so plus square root of 3 pi divided by 6. Now, is that plus 1/2 or minus 1/2? Plus 1/2. There's an X over here. And I like changing that color to actually red. So I think it enables you to see it a little bit better. So here's my point. Isn't that what we're talking about, I guess, that line? Okay, if I can do a little bit more of that. Do a little bit more showing off here. Again, it's going to be all the way at the bottom. Cut. So this is the tangent line that they're talking about. So it actually looks pretty good to me. All right, good. What about this next one? Again, this is my x and y coordinates. Is that right? This is the one and only point where m y minus y1 is m tangent x minus x1. So this is my orange. X1, Y1 is green. 1, pi over 4 m tangent. So we need m tangent. So, well, the definition of m tangent, as we have seen, is the derivative of, what's the curve here? The curve happens to be what? Tangent. Is that right? So if you have the tangent curve, and we got to evaluate this at the value x equals, I believe, 1. Is that true? No, pi over 4. Okay, pi over 4. All right, what's the derivative of tangent? Secant squared. So this will be secant squared now evaluated at x is pi over 4. And let's plug that in. Okay, now let's remember a few things here. Secant to the second power, this is my notation. This is just squaring secant. In other words, that's our notation. The definition of secant is the reciprocal of cosine. And then I know something about pi over 4. What's pi over 4? Isn't that going to be what? That's 45 degrees. So again, I have a special triangle. Whether I go back to trig or geometry, the 45, 45, 90 degree special triangle, I got 1, 1, square root of 2. Is that right? I can say cosine of 45 degrees. What is that really going to be? It is adjacent over what? Hypotenuse. Is that right? So I can plug this value in right here. I can say, well, that's going to be 1 over the square root of 2, which means I have 1 over 1 divided by the square root of 2 to the second power by using some of the algebra or arithmetic. Isn't that just the square root of 2 squared? Which will be what? Which is 2. So double check, ladies and gentlemen, that m tangent is the value 2. Okay, I think I'm okay. But notice there's the trig, geometry, whatever you want to call it. Not too bad. So I get to plug this value in. And we could now find the equation of the line tangent to the curve at the indicated point down here. If we say, okay, y minus 1 is 2 x minus pi over 4. I could distribute the 2. And I get 2x minus really pi over 2. And so I can add my 1. You get y is 2x. I'm going to say plus 1 minus pi over 2. I'm going to write that down. This is our tangent now. Okay. So double check this, 2x plus 1 minus pi over 2. I'm going to add a sheet here. 2x plus 1 minus pi over 2. Was it minus pi over 2? Yeah, it looks like. I'm going to change the color to red. And it does look to me like you are kissing the curve at that location. So I'll do a little bit more showing off here so you guys can see this is what a tangent line looks like over and over again, just kissing that what? that curve. Then I'm going to go all the way down here and cut it out because it puts it at the end. We'll paste it. So this is using some of the technology that you guys can see that's what a tangent line looks like. It's kissing the curve at that location. It's going through that point. It's barely touching. So it looks like everything we've been doing has been fine. If it doesn't look that way, then you know there's a problem. All right, you guys okay with that one? So isn't that kind of combining everything that we looked at before in the past? And then now we have another thing. I mean, I could have you guys work on this. Well, let's talk about this one. This is going to be interesting. Okay. This location you got your one and only point here. And if I said to you guys, take a look at this curve here. This tangent line should be what? Do you guys know? What does that look like to you? You're barely hitting the curve and you're going through that point. That's our tangent. What do you know about that line? It's horizontal. Is that true? You have a horizontal tangent. When you have a horizontal tangent, what do you guys know? M tangent should be 0. Okay. So as we look for the equation of the tangent line, since that's the instructions, we're going to go through the same process. Orange, I guess, for my x-coordinate, green for the y-coordinate. So I will plug in square root of 2 here. Let's do it in red. And then what will I plug in over here? This is pi over 4. Is that right? Okay. So now we just have to get the derivative. Is that right? Of sine plus cosine. M tangent again, by definition, is the derivative of your function. What's the function? It's sine plus cosine. Is that right? Okay. So the derivative of sine plus cosine, and then we have to evaluate this at x is pi over 4. Okay. So what do you guys remember? You got to use the derivative of a sum is sum of derivatives. Is that right? And essentially, we want to know what's the derivative of sine? What's the derivative of cosine? Maybe you want to see, maybe I should write it down, every detail. This is part of the proof I sent you guys this weekend. Is that true? Do you guys know what I'm talking about? Yep. Derivative of sine is cosine. What's the derivative of cosine? Okay, so this is going to be cosine minus what? Sine. And we evaluate this where? Pi over 4. So this means cosine 45 degrees minus sine of 45 degrees. Do you guys remember, just by looking at that triangle I drew over here, both cosine and sine are what? Aren't they the same? And 45 degrees is pi over 4, so those are the same. So just knowing special triangles, you go, oh, okay, this is going to be 1 over the square root of 2, and this is also 1 over the square root of 2. So what's that difference going to be? Yeah, that's going to be 0. So sure enough, M tangent is what? 0. You got a horizontal tangent line. Anytime that's equal to 0, you have a horizontal tangent. So what's the equation then? If you said, well, this is 0. Yeah, let's get this here. Well, then that means you simply have what? Y minus 1/2 equals 0 times x minus pi over 4. Is that right? Was that what it was? Oh, y minus the square root of 2. All right, wasn't 1/2. Good. So y minus the square root of 2 will be 0. And add your square root of 2 to both sides. You now get the tangent line to be a constant. It's the square root of 2. That's the equation. This is the equation of the tangent line being the square root. So in Desmos now, y plus cosine, here you go. And I'm going to add this function here, where y, this is the tangent line, the equation of the tangent line. It is constant here. So what I want you guys to really see is, sure enough, that is a what? Horizontal tangent at that location here. Okay, it is horizontal. Pretty nice. Pretty good. So these are going to be some things we have to really start to use and remember. They're going to be so important for us. Add to existing. No, where are you? Okay. I'm going to go all the way at the bottom. And cut. All right. So yeah, sure enough, there's our altangent. It's the square root of 2. It's a horizontal tangent. Slope is 0. Now, what do you guys think? Isn't this exactly what we did before with the other functions? All this work, finding the equation of the tangent to a curve at a location, at a point. Now, this next question here, I'm not going to go through this one. Okay, we're going to try question 5. As soon as the I pencil connects, and we got a connection there. So this is finding the equation of the line tangent to the curve at the indicated point here, where this is the one and only point they gave you. You got your x coordinate, y coordinate of that one and only point. So we have y minus y1 is m tangent times x minus x1. So we already have the x1 and the y1 values. We just have to find m tangent. So we get 0 and pi over 4. So m tangent for sine minus cosine at pi over 4 now. Okay. Sine minus cosine. So Derivative of a difference is difference of derivatives. Now this is M tangent. The derivative of sine is cosine. The derivative of cosine is minus sine. So M tangent becomes cosine. Don't forget this is minus a minus, which makes that plus. At x equals pi over 4. So we're going to get cosine pi over 4 plus sine pi over 4. Okay. And we've seen from the past that this is 1 over the square root of 2 plus 1 over the square root of 2, which is actually going to be the square root of 2 over 2 plus the square root of 2 over 2. So M tangent is simply the square root of 2. So this value goes up here. All right, so wherever this is at, okay. All right, well, this is pi over 4, so let's do this up here. This was the square root of 2. Sorry, we're in number 5. We just have to find where we're at. Okay. All right, let's try this again. Can we do that? Yeah. Anyway, square root of 2. So let's try it right here, I guess. I don't know what to say. Y minus 0 is the square root of 2 x minus pi over 4 now. Which means y is going to be, if we distribute here, the square root of 2x minus the square root of 2 pi over 4 here. This is that equation of the line tangent to the curve. This is our L tangent now. Sine minus cosine. So this is number 5 here. Let me see if I can even try to do that. I guess I'm on, does it know what page I'm on? 12. And it doesn't think I'm on page 12 here. So let's just do this in Desmos here, okay? So sine minus cosine. Okay, and I believe the point was number 5 here. Maybe I have to go back and do that here. We're going Add a page. Yeah, there we go. Okay. Finally. Pi over 4 is 0. Okay, pi over 4 is 0. Now let's add this tangent line so we can see it. Y equals, I think it was a square root of 2x minus square root of 2 pi over 4. Let's see. It's cosine, sine minus cosine. X is pi over 4. Okay. Something's not right. Sine minus cosine. There it is. That's sine minus cosine. All right. Now we're perfectly fine. Okay, sine minus cosine is the curve here, not cosine minus sine. That's the difference there. So I'll fix that on the sheet, but in our solutions, there it is. All right. So it's the wrong curve on that sheet, but okay, I'll fix this. Number 5 goes right here. So we do see the curve with the tangent line barely kissing at that location, barely kissing the curve. There you go, that's number 5. I want to start talking about number 6 here. I'll probably send you later on today, oh, how do we do number 5, like I usually do. But I want to talk about this one here, because what are they doing now? They transitioned here. What are they going to say? Determine what? The location of horizontal tangents for this curve right here. And it's over a particular interval. This is over what we call in trig. This was a restricted domain. This is not all real numbers now. You restrict your domain to only be from 0 to 2 pi. So you're looking at particular solutions and not general solutions over that interval from 0 to 2 pi. It's over that circle. So if you guys took trig, you guys remember some of these kind of things. These details are coming back. Now, what's the question? When they say determine a location, they want coordinates. They want an XY coordinate. Where you have a horizontal tangent. So I abbreviate this horizontal tangent, and I want you guys to remember this means where M tangent equals what? 0. So your task is to find the location, the point where m tangent is 0. The slope of the tangent line to the curve at any point, you don't know what they are, needs to be 0. So you go to the function and you use the definition. You say, okay, m tangent is what? The derivative of the function to what? Sine x plus what? Cosine x. Okay, and that needs to equal what? 0. So what that means is, I'm going to use properties here. Let's get out some more of this. I guess I'll do every detail. That means your derivative of 2 sine x plus cosine x becomes 0. So by properties again of derivatives, derivative of, well, all right, let's do every detail here. Derivative of a sum, I sent you guys that proof this weekend. 2 sine x plus the derivative of cosine x equals 0. And then pull out your constant. Okay. All right. Okay, what's the derivative of sine now? What's the derivative of cosine? Okay. Isn't that good to know? We're saying 2 cosine x minus sine x equals what? 0. Okay, you guys okay with that? So what do you have to do with this at this point? You have to solve for x. What is this known as? Do you guys know what you're looking at? This is called a what? A trig what? Equation. And where do you solve trig equations? Trigonometry. All right, so you got to go back to that information and say, okay, I'm going to solve a trig equation using trig. All right. So if you guys recall, you can add sine to both sides, and you end up getting 2 cosine x is sine x. I'm going to divide both sides by cosine, and I'm going to use a nice identity. On the left side, you got cancellation. On the right side, anybody remember, what is this here? What's sine over cosine? It's tangent. So you have tangent x equals the number 2. And this is over your restricted domain from 0 to what? 2 pi. Okay. So let's go back to trig and ask people, what does this actually mean now? Okay. Because we got to solve a trig equation to find those locations here. And I'm going to need more paper here. What does that mean? Well, this is what I do in the trig class. I got to go all the way back to some, look at all these things I created. I'm looking for my all students take calculus. There we go. why do I care about all students take calculus? What I want to remind people is 0 to 2 pi. The angles you have from 0 to 2 pi, these are radian measures, right? So I'm only talking about really one full revolution because you restricted the domain here. What angles in radians does that really correspond to where tangent is 2? Now, the truth is you would kind of have to use a calculator, sort of, in a way. And you want it to be in radian measure. But I can tell you guys, we can solve for x. I can say, well, I know that happens when x equals the inverse tangent of what? 2. And this will be a quadrant 1 solution. Okay? So that solution here, if we go back to some of these ideas in trig, is like somewhere over here. It's a quadrant 1 answer because quadrant 1, what I say, is your reference quadrant. If some of you guys recall some of that, that's the reference quadrant. How do I get any other possible solutions? Well, you guys remember, all students take what? Calculus. What does that mean? What do you guys think that means? My second solution is going to be where tangent's positive again. My second solution is where? Quadrant what? Isn't it a quadrant 4 solution? I'm sorry, quadrant 3? Sorry. I did drink Husky coffee, but I'm still asleep. Quadrant 3, because this is the meaning of t. T is positive. And this differs by what? Do you guys recall? Yeah, by pi. So if you said, Mr. Judge, what's the next solution? Well, it would be x is what? Inverse tangent of 2 plus what? Pi. There you guys go. So there's 2 quadrants. There's really 2 solutions. And it kind of makes some sense because if you go back to the picture here, right? This is the location of inverse tangent of 2. You will have a what? Horizontal tangent. Slope of the tangent line is 0 here. So just looking at the graph, I can say, there is one point. And then down over here now, there is another location. Where you have a horizontal tangent and that M tangent is 0 here. So I did want to go through that and show you guys those pictures today. And then that happens over here at what? Inverse tangent over 2 plus what? Plus pi. Those are the two solutions. But then again, you say, but what do they want? Well, they want the x and y coordinate. You only found the x coordinates. And so your function is 2 sine x plus cosine. So I'm interested in something here. I wonder what this is going to be, right? Make sure you're in radians. 2 sine inverse tangent of 2, close that, plus cosine, and I screwed up, cosine of what? inverse tangent of 2. Close that again. Oh. All right. Well, here's what we can do. Sometimes when you're looking back at the book to give solutions here, this is what they're going to say. The first x-coordinate was inverse tangent of 2. And then you'll say this is f of what? Inverse tangent of 2. There's your x and y coordinates. And then the next one will be, oh, inverse tangent of 2 plus pi, f of what? Inverse tangent of 2 plus pi. And these are the x and y coordinates, and you could kind of get away with that, I guess. Sometimes that's a nice answer, but anyway, this is kind of an interesting kind of question here. Okay. Now, I want you guys to note something here, just to kind of keep this open and connect the dots, right? So let's say you go over here. I'm going to go over to Google. And in all honesty, I do have here the Google browser now. Okay. I think what I can do here, go back to the question here. Let me see if I can type this in. I can say, well, I can do two things. Yeah, I'm going to type it in. Determine the horizontal tangents for y equals 2 cosine x plus what? 2 cosine, 2 sine x. Plus cosine of x over, I'll say 0 to 2 pi. Let's see what happens here. Okay. Now this is Math GTP. If you're stuck on your homework, take a look. Yeah, so far so good. It looks pretty good to me. Is that right? Find the corresponding y values. Answer. This is your answer here. Now, let's say you read this and you still say, I don't even know what they're talking about. Well, you can create a video for yourself. And it'll narrate for you and create a video so that you can watch about really how to get the derivative and solve a trig equation. And that's if you don't want to watch look at my resources, because I could show you where my resources for that as well. But as you guys can see, you guys have a kind of a lot of resources, and that's coming up. So I did want to share you guys, this kind of information. Hopefully you look at that and go, okay, it might take some time, 5 minutes, who knows? But yeah, those are all the details now. All right, let's see how long that takes. So I guess if it's in the middle of the night, you're working on your homework, you get stuck, nobody's around. Well, you have this option as a tutor. Like I said, I do send you some trig and algebra. I'll send some more trig equations again to people. I always do. You'll see more trig. Even if you look at this, you go, oh my gosh, that's a lot of trig. Well, trig is in Calculus 1. This is why ChatGPT said what they said, as you guys can see. And there's more trig, though, in Calculus 2 and Calculus 3. So if your intentions are to take Calculus 2 and 3, I would not be of the philosophy or the hope that you can sign up for a math instructor that skips all the trig. And if you find somebody who does do that, they're going to do you a great disservice, meaning you're going to be stuck in the sand. Because trig doesn't go away. It's in your science courses as well. It's not just calculus. So it's very short-sighted for people to give you the advice of skip trig. Oh, just go get some tutoring and your life will be good. Or then maybe you pray the instructor doesn't give trig. Or maybe if they do give trig, it's only 1 or 2 questions. You guys know what I mean? People think that way. That's just not the way you think to be successful. Because I think your life is meaningful. And what you do in it is meaningful. If you like yourself, you'll help yourself. But hey, some people have to learn this the hard way. And that's fine with me. I go home and I'll sleep like a baby. Let's take a look at the video.
In this lesson, we will determine where the curve y equals 2 sine x plus cosine x has horizontal tangents on the interval from 0 to 2 pi. We will compute the derivative, set it equal to 0, solve for the x values, find the corresponding y values, and confirm on a graph. Step 1. Compute the derivative. Our function is y equals 2 sine x plus cosine x. The derivative is y prime equals 2 cosine x minus sine x. Step 2. Horizontal tangents happen where the slope is 0, so set y prime equal to 0. 2 cosine x minus sine x equals 0. Move sine x to the right to get 2 cosine x equals sine x. Divide both sides by cosine x to get tangent x equals 2. Step 3. Solve tangent x equals 2 on the interval. The general solution is x equals arctangent of 2.
And that's true. But you'd have to know about all students take calculus to figure out the rest. So if you took trig, you guys know I went through those details, all those details. But anyway, I just wanted to share that with you guys as another option. I think they charge like $10 a month because they only give you like 3 or 4 freebies. And I signed up. I had to pay $10, like I said, for this a month. So this is another option for students. And you'll get the same answer. But I give, these solutions that are more detailed. And so you might prefer those. I don't know. But it's not the answer to everything because, it does give you a solution. But if you don't know what the details are, it's kind of, it defeats the purpose in my opinion. But in trig, I go over the all students take calculus. There's a whole, and I can send you guys the whole videos of that, where you have solutions in opposite quadrants. So you add a multiple of n pi. If the solutions are not in multiple quadrants, you add 2n pi. It's that kind of thing. Let's do some more calculus, though. All right. Same question. What do they want here? Horizontal tangents. What's the story with that? Horizontal tangents. They want those locations. They want to know where M tangent is what? 0. Okay, so what is M tangent? M tangent, by definition again, is the derivative with respect to x. What's your function? Cosine minus sine, and notice it's over the restricted domain again from 0 to 2 pi. All right, pretty nice. Now, M tangent, derivative of cosine minus sine. And, sometimes I've said, okay, that has to equal 0, which means the derivative of cosine minus sine must be 0. And then the derivative of a difference is difference of derivatives. Okay. All right, what's the derivative of cosine again? Negative sine. What's the derivative of sine? Cosine. Okay. Minus sine minus cosine is what? Equal to 0. Okay. Do you guys remember this from trig? I know I do. what I can do is I can actually add sine to both sides. Is that right? AI is going to say, hey, move sine to the other side, translate that, and that gives you minus cosine is sine. If you translate it, move it to the other side. Now divide both sides by cosine, and you get cancellation. Use your identity here for what? For sine over cosine. And what's sine over cosine now? So this is the very famous tangent x is -1. So you have to answer that question. What is x over the interval from 0 to 2 pi now? So let me bring in our all students take calculus, because there we go. Because this time you're going to need that reference angle, right? And let me ask you guys. Remember, you said, what do you mean you need a reference angle? Well, you have to always start by doing the quadrant 1. And I'll use notation from trig. You need the quadrant 1 solution here. Okay? And tangent of that reference angle. You guys know, what's the reference angle when tangent's 1? Isn't that what? It's pi over 4. Is that right? Because you use the definition of tangent. You say, oh, opposite over adjacent is 1. That means this angle is pi over 4. 45 degrees. So it's a 45-45 special triangle, 45-45, 90. But the solutions are not positive. The solutions are really what? They're negative. So you go, okay, where do I have, what quadrants have negative tangent? Yep, 2 and what? 4. And again, this is the opposite quadrant situation. So you might say, well, how do I find the angle? Well, for quadrant 2, it's pi minus the what? Remember that pi minus the reference angle? So the reference angle is pi over 4. So it'll be pi minus pi over 4. This will be the first solution. Okay, and then I showed people in trig how to take a whole number and subtract it with a fraction. Right? Use that 4 over 4. So that first solution for theta becomes now 4 pi over 4 minus pi over 4. What's that first solution? You get 3 pi over 4. Okay. And then you say, well, what about the quadrant 4? Well, I could do a couple of things. I could use this equation we study there. Yeah. The angle is going to be now 2 pi minus pi over 4. That's for the second solution. Or I can add a multiple of pi over 4 to the first solution. It'll be the same. So you get now, for the second answer, 8 pi over 4 minus what? And what does that equal? It's 7 pi over what? 4. Now, they didn't give you what? Theta. This was x. So the first x-coordinate solution is 3 pi over 4. The second coordinate solution is 7 pi over 4. Those are the two locations. So if you had to give a point, a quick and easy way to do that, an x and y coordinate, here's what I'm saying. You got x and y, but you know y is f of x. Is that right? So you can say, my first location is 3 pi over 4, comma, f of what? 3 pi over 4. And the second solution is 7 pi over 4, then f of 7 pi over 4. Again, those are the two locations where you have horizontal tangents. So 3 pi over 4, 7 pi over 4, at this picture, this is where 3 pi over 4 will be. And over here, you'll have 7 pi over what? 4. And I won't go into Desmos and blah, blah, blah. Show you guys that. All they want to do is find locations of horizontal tangents. Horizontal tangents happen where that derivative of the function is 0. So we can do this for sines and cosines. You know, we can do this same process for trig functions, but as you guys know, you're going to have to solve a trig equation. So you're going to have some knowledge of how these functions look, behave. And let's try this one, see if we can squeak it in here. I can see already there's what? Just by looking at the picture, I can see there's two horizontal tangents. Is that right? But let's go through some of this. And again, it's nice that they restricted the domain. That means it's only from 0 to 2 pi. The function now is cosecant now. Okay. So m tangent will be the derivative of what? Cosecant, and you set that equal to 0. What's the derivative of cosecant? Isn't that negative cosecant cotangent equals 0? Okay, here's what I'm going to say. Here's what you guys want to know. What does this actually mean? Whenever you have a product here of two functions and it equals 0, let's get out some algebra. If a times b is 0, what do we know? Then a is 0, or yes, the zero product rule. It's called the zero product rule from beginning algebra. So it shows up a lot in calculus. You're going to see this. And I put this t because it says, okay, minus cosecant is 0, or cotangent is 0. What do I know about the cosecant curve? This is never what? 0. This doesn't what? This doesn't happen. Now, how would you know this? Well, when you go back to trig, I ask my trig students, please, trig students, we study what? Graphing. Like I said, what is cosecant? Here's cosecant. Does it ever cross the x-axis? So there's no intercepts. That's what that means. And then if I put that negative sign in front, it just, reflects your curve about the x-axis. It still never crosses the x-axis. So cosecant's never 0, if you guys recall. But what do you guys know about cotangent? Yes, there is a 0. There's an intercept. Now, how would you know where that is? Because you remember how to graph cotangent. And, I could go back with the graph of cotangent. But I can show you guys again, cotangent is 0. It happens at pi over 2. It also happens where? At 3 pi over 2. So we can find that by graphing cotangent, going back to our fundamental curves that we graphed in trig. What's the solution? Pi over 2 and 3 pi over 2. So this happens that x is going to be pi over 2 and x is 3 pi over 2. This is, you go back to the graph of those, of graphing cotangent, really. Pi over 2 and 3 pi over 2. So like we said, there's two locations here. This will be pi over 2, and then this will be what? Where x is 3 pi over 2. I want you guys to see this. Yes, it's both an x and a y coordinate here. We got to find the y coordinate. So if you want to put the solutions here, this is cosecant. So you can say, okay, my first solution is x is pi over 2, comma, f of pi over 2. And you can find cosecant pi over 2 if you wanted. Okay. I think it's going to be 1. So we can write it that way, or we can say, this will be what? 1, and then the second, 3 pi over 2. You can say, this will be f of 3 pi over 2. But since the function's cosecant, it's a really simple function. This is going to be -1. We're looking for the location there. Pi over 2 comma 1. 3 pi over 2 comma -1. That's the location. So we can put that up here as well. It's a nice simple function. But looking at simple functions, we could learn a lot as well. These are locations of horizontal tangents. All right, you guys okay with that? So what I'll do when I get home tonight, I will finish this off for you guys and send it to you probably after the Dodger game. You guys know what I mean? It starts at 3, and just give me a little bit of time for myself, if I can, to watch the game. And if they're getting blown out, I'll get mad and say, forget it. I'm going to get started on sending this stuff to you guys. But if not, I'm going to have a good time. What do you guys think? Not too bad? Well, what do you need to know to do Calculus 1 again? What would you tell your younger brothers and sisters? Stay in your algebra courses and your trig. Don't leave them. Is that right? I'm going to make a t-shirt. We got to find a slogan. I'll design a t-shirt. Got to find something kind of cute. Instead of got milk, got algebra, got trig. You know what I'm saying, you guys? You should understand that now as you've seen some of these as we proceed. Okay, you guys, have a good day. Let's hope the Dodgers win. I'll see you guys tomorrow. I'll fix that curve. And then now we're back to doing horizontal tangents for number 9. They want to know what's the location. We have horizontal tangents. That's when that m tan equals 0. So, okay. And I can actually see right here, there's only one horizontal tangent, just so you guys know. We're going to show this, that there's only one. Well, actually, there might be more. Here and here. Let's double check here. So, m tangent is going to be the derivative of secant. So you set this derivative equal to 0, meaning the derivative of secant will be secant tangent. Now that is 0. Okay. So by the zero product rule now, like we seen earlier, whenever we have a product that's equal to zero here, you got the first function times the second function. By the zero product rule, that means either the first function is zero or the second function is zero. Now, this never happens. Okay, your secant curve is never zero. Doesn't happen. So remember, we're restricting the domain here from 0 to 2 pi. So it doesn't really matter. Secant is never 0. In fact, you're looking at the secant curve right now. This here is the secant curve. So what that really means is there's no x-intercepts. Setting that equal to 0 means, there's simply no x-intercepts on your curve. And there are none. You're looking at secant. This is the x-axis. You have no x-intercepts. Okay, but tangent can be 0. And so you have to remember, where is tangent 0? You got to go back to the tangent curve. That happens when x is 0, x is pi, and x is 2 pi. Because if we go back to maybe Desmos again, and we just want a tangent curve. Here's the tangent curve. And let's say this is from 0 to 2 pi, so I'm going to restrict my domain. I'm going to remind you about your graphing skills. This is 0 less than or equal to x, less than or equal to 2 pi. Now, where do you have zeros here? You have 0. Tangent is, they're really intercepts. At 0, pi, and at 2 pi. So sure enough, this is where your tangent curve over that interval from 0 to 2 pi is equal to 0, really the x-intercepts. So we were correct here with our 3 solutions here. So yes, at this location, this is when x is 0. Over here, this is x is 2 pi, just so you know. And then this is going to be where x is simply pi here. So these are the values of x where you do have horizontal tangents, those tangent lines here, have a slope of 0. Now, just looking at this curve as well, we know that this is the coordinate of x being 0, y being 1. This is pi negative 1. And then this will be 2 pi 1, just by notating these locations on the curve. So if you said, what are the locations? 0, 1, pi negative 1, 2 pi 1. This is where you have horizontal tangents for number 9. M tangent is 0. Okay. Number 10. Now, if we look at this curve, there's no restriction on the domain, just so you guys know. This is for all real numbers. They didn't restrict the domain, so the interval is all real numbers. But let's take a look at what happens with this. If you take a look at this curve, I don't think I see any horizontal tangents. So M tangent is the derivative of tangent, and we have to set this equal to 0. So that's what we're looking for, right? You say M tangent is 0 when you're seeking the horizontal tangents. All right. the derivative of tangent is secant squared. The definition of secant squared is really secant to the second power. So by algebra, if you have I'll call it b for base. If you have the base to the second power, then that means the base can only be 0 here. This is another extremely important algebra fact. If b squared is 0, then that means b is 0. And what that means here then is secant is 0. And we just got through saying that this never happens. The secant function could never be 0. And if we went back to the secant function here, remember, there's no x-intercepts. You never cross the x-axis. So secant is, in fact, never 0. So you say, well, what does that mean? If that means there's no horizontal tangents. And that's what that means. Anyway, I'll send this to you guys, and I hope you enjoyed.